So going through, taking a look at the first few questions they had to create.
Hi.
All right, remember we are going to be talking about two formulas today for right triangle review.
Hi.
All right, we're going to be talking about our Pythagorean theorem, a squared plus b squared equals c squared. And remember, we're using that when we're only talking about the side lengths. Okay, two sides looking for the third. And then we have our Sohcahtoa. All right. And so remember, we're doing this when we're talking about a side and an angle. Really, the angle is the key part here. When you have an angle, you're going to be leaning towards Sohcahtoa. So you're either solving for an angle or using the angle. So we're going to find the measure of each angle. Remember, theta is our mystery angle we're trying to find. So once again, when you're using Sohcahtoa, make sure you label your sides, hypotenuse across from the right angle, adjacent connected to the angle, and opposite the leg across. Okay, so we can see for this triangle, we have adjacent and hypotenuse, so we're going to use the cosine. So remember, it's cosine theta equals adjacent over hypotenuse. All right, see if you can set up the other ratios for these, and then we'll come back in a second. So pause it, see what you can do. All right, so hopefully you guys ended up with these ratios. For the first one, we did adjacent over hypotenuse, so 12 over 13. And then remember, theta is going to equal, we need to get rid of the cosine. So remember, we're going to do the cosine inverse of cosine of theta, and then cosine inverse of the fraction, the ratio. So the cosine and cosine inverse are going to undo each other, leaving us with a final answer of 22 to the nearest 10th, 0.6. Okay, so on your calculator, remember you're going to do, from the calculator screen, you're going to press the trig button, okay, which is next to the number 7, and then choose cosine inverse, and then type in that ratio. We'll get that up here in a second. You can see that. On the second one, we want to undo tangent. So what I really need to see from you when you're doing this is at least that theta equals the tangent inverse, okay, of 4 over 13. And then you can tell me what your answer is. But really what's going on, even though you're not showing it, is you're taking the tangent inverse of tangent theta, and that is undoing each other here, okay? And then the tangent inverse of 4 over 13 is going to be 17.1. We're going to do cosine, same thing here. So theta is equal to the cosine inverse of 6 over 9, all right, which is equal to 48.2 here. And these are all degrees because they're angle measures. And then same thing here. So tangent of theta, because it's opposite over adjacent, is 11.9 over 10. So theta is equaling to the tangent inverse of that 11.9 over 10. Now, not multiplied, but you're actually evaluating this function at that x value, okay? And this is equal to 50.0. It's 49.95. All right. And then we can see the next one is opposite over adjacent again. That's tangent. Theta is equaling to the tangent inverse of 7.7 over 14. Okay. And theta is equaling to 28.8. And then cosine, adjacent over hypotenuse here again. And then theta is equal to the cosine inverse of 4 over 5. And so that is going to give us 36.9. And those are good degrees. Just putting that little circle there for degree. Okay, so that's how essentially we're handling these ones. But remember, what is actually going on is we're taking the tangent inverse of the tangent of theta. Okay, that's what's undoing. We're doing the cosine inverse of cosine theta. Okay, and that is what's undoing here. So the tangent inverse of tangent of theta. Okay, so keep that in mind, that even though you may not be writing it, this is still what's going on. Okay. Going on to the next one, see if you guys can find the missing side. So let's see if you can set up those ratios first, and we'll take a look at that in a second. Oh, let's watch the first one, and then we'll take a look at that. So once again, we're looking for a side length. We have an angle, so that tells us we're going to use Sohcahtoa. Okay, so once again, we're going to go label our sides. Here's opposite, here's adjacent, and here's our hypotenuse. So since we're using adjacent and hypotenuse in our Sohcahtoa, that would be our cosine. So the cosine of the angle is equal to the adjacent over the hypotenuse. You don't have to write this every time, as long as you can fill that in for yourself. So cosine of 37, and that's 11 over x. And then from here, whenever we're looking for a side, we cross multiply. So we're going to get x times the cosine of 37 is equal to 11 times 1, so that's 11. All right. Just cross multiplying here. And then we divide out by the cosine of 37. This is 11. And that is going to give us our answer. So take the calculator. All right. In a calculator screen, we're going to go ahead and press trig. Okay. We're choosing cosine. That's great. Well, that's a little crazy. Cosine. All right. And then our numbers, once again, were 11 over 37. Oh, now 11 over 37. 11 over the cosine of 37. So timeout. Let's rewind this. Not the cosine of. We're not doing the angle anymore. It's 11 divided by the cosine of 37. And then rounded to the nearest tenth. So this is 13.7. The next number isn't a 7, so it rounds up. So it's 13.8. All right. And that's our answer for number 9. Okay, see if you guys can go about in setting up the ratios for 10, 13, and 14. Apparently we're hating on 11 and 12 here, but that's okay. All right, so for number 10, hopefully you notice we're using opposite and adjacent, so we're going to do the tangent of our angle. So tangent of 32 is equal to the x opposite over the adjacent 13. Cross multiply here to get 13 times the tangent of 32, and then you're going to type this right into your calculator. It's 8.1233, so nearest tenth would be 8.1. All right, for number 13, once again, we're using opposite and adjacent here, not the hypotenuse, so tangent should be the correct choice. So tangent of the angle, 41, equals opposite 4 over the adjacent x. Cross multiply again, so we're going to do x times the tangent of 41, and then 4 times 1 here, so 4 equals x tangent of 41. Divide by the tangent of 41, and we should get 4.6014, so that rounds to 4.6 here to the nearest tenth. And then last but not least, our first instance of sine here today, opposite over hypotenuse. So sine equaling opposite over hypotenuse, sine of 57 equals the opposite 10.8 over x. Cross multiply again, it's x times the sine of 57, okay? And then divide out by that sine of 57 to end up with a final answer of 12.877. So since the second number is a 7, it does round up to 12.9. Okay? Any questions? Let me know, but those would be the answers to the first page here. So let's go down to the next one. All right, height of a vertical cliff, and it mentions angle of elevation here. So that tells me right away we have a right triangle, okay? So we have a cliff. All right, and the cliff is 450 meters, so that is this side of our triangle. We have a boat. Not a boat, here we go. All right, and the angle of elevation to the top of the cliff, so the angle of elevation being drawn to the top of the cliff is going to be 23 degrees. It doesn't say where on the ship, so it doesn't say like from the top of the bottom. So we're just going to go that it's right to the bottom of the ship, making a right triangle here. And remember, angle of elevation is looking up, angle of depression is looking down. These two angles are congruent. So whether it tells you it's the angle of elevation or depression, we always want to make sure we're putting it in the bottom corner so that it's inside the triangle. All right, we want to find The ship is X meters from the bottom of the cliff. We want to kind of show this. So this would be our diagram. So I do suppose we should actually put this over here. All right. And then it says calculate the value of X. So once again, we're going to find our reference angle. That's the 23. We're going to label our sides. So 450, opposite X is the adjacent leg, and we have our hypotenuse. So we're using the opposite and adjacent. So if you need to use your reference of Sohcahtoa, go for it. All right. And since we have O and A, we're going to do the tangent. So the tangent of the angle, 23, is equal to the opposite, which is 450, over the adjacent X here. Okay. We're going to go ahead and cross multiply because we're looking for a side. And we're going to get 450 is equal to X times the tangent of 23. Whether you put a capital T or lowercase t makes no difference. And then we divide by the tangent of 23. And we'll have our answer. So nearest hundredth here. So 450 divided by trig tangent of 23. And we're going to get an answer of 1060. We're going to the nearest hundredth, so it's 0.13. The next number is a 3, so it stays as a 13 here, 1.13. So 1060, 0.23, sorry, 13. And we're talking about meters, so this is also measured in meters. So make sure we put our units down there. All right, that's number 15. Number 16, the diagram below shows the two triangles. It says tangent is 3 over 7. Now here's theta. So when we say tangent of theta, we're actually talking about this triangle right here, okay? What this means is that from this angle, okay, since tangent of theta is equal to the opposite over the adjacent legs, that means the opposite leg is 3 and the adjacent leg is 7. So I can know that this leg is 3 and this leg is 7. I want to find X to the nearest tenth. So there's a couple ways that we can go about doing this. Number one, we know that these two triangles are similar. So whatever the measure of, right, we could make a ratio of the sides because we know that this side 7 corresponds to X, okay? That 7 corresponds to the X and 3 corresponds to the 2.4. So we could just say 7 over X is equal to 3 over 2.4, and now I can cross multiply and solve, okay? So that's one option. We'll follow this through. We'll multiply, cross multiply. So 3 times X is 3X. That's actually going to go on the other side. And 7 times 2.4 is 16.8. And then we'll just divide by 3. So answer divided by 3. We're going to hit enter, and we get 5.6. Okay, that's one option. Option number 2 is actually to use the angle measure, right? Because this angle, if you remember, is equal to this angle in our triangle. So whatever theta is, this is the same number of degrees. Okay, so I can use tangent here to solve. So if tangent of theta is equal to 3 over 7, then theta equals the tangent inverse of 3 over 7. So if we go trig, tangent inverse, 3 over 7, we're going to get this answer right here. Now, we shouldn't really round this. We kind of want to use this as is. So we'll just leave this as, we can leave it as this, or we can write it out, 23.1958. And we don't want to round this because if we round, we're going to get an incorrect answer. And also it's 85, 1985. There we go. 905136, 905136. So now in this triangle, we're going to do the same thing. We're going to say that the tangent of theta, okay, is equal to the opposite over the adjacent. And we'll just leave theta as this because we already know what theta is. So that's 2.4 over x. and then we can cross multiply here. So we're going to get 2.4 is equal to x times the tangent of theta. And then we can divide out by the tangent of theta. I don't have to write that ugly, this 2.23.1985. I can just leave it as this. All right. And then on my calculator, I'm just going to do 2.4 and then divided by, we're going to do trig tangent. And then what we can do is just press the up arrow to highlight the answer. The up arrow one time. Using the board here. It seems to really like to go extra far there. And then when we hit enter, notice we'll get the same answer here. So we'll also get 5.6. So we're using this whole answer instead of rounding. Now, if we rounded, and let's just say, oh, that's like 23.1, right? Then when we did this, okay, and we rounded to the nearest tenth, we still get 5.6. But if we rounded to the nearest hundredth, right, we'd end up getting 0.63 when it should just be 0.6. So you can see there's a little error here because you're rounding. It's kind of messing with this a little bit. And we're getting a little different answer. Okay, number 17. Remember, we have a right triangle, ABC, with a right angle at C. We had a question similar to this one on the other day, right? So if we know that angle A plus angle B is equal to 90, then we know that the sine of A is equal to the cosine of B. And remember, the sine of A is this, okay, expression. And the cosine of B is this expression. So all we're going to do is set these two expressions, 3x plus 0.5 equal to 5x minus 0.1 and solve. So take away the 3x from both sides. That'll leave us with 2x. We can add the 0.1 back to the other side just to save some space here. You get 0.6 and then divide by 2, and 0.3 is going to equal x, okay? And then the reason is, all right, that we can do this, explain our answer, is this is our explanation. So since angle A plus angle B is equal to 90, the cosine of A, which is true, really we want to say the sine of A, because that's what we're given here, not cosine. So the sine of angle A is equal to the cosine of angle B. That's our explanation. Okay, number 18, find the value of R that makes this equation true. Just remember, if the sine of A is equal to the cosine of B, then what do we know? We know that angle A plus angle B is equal to 90. So if we use this statement, we could say that if the sine of R equals the cosine of 53, then it must be true that R plus angle R plus 53 has to equal 90. So we can just subtract 53 away from 90 and we'll have our answer here, okay? And angle R is going to equal 37 degrees. All right, and this is our explanation right here. If sine of A equals cosine B, then angle A plus angle B is equal to 90. Okay, in the diagram below, right triangle ABC, altitude BD is drawn. Which ratio is always equivalent to cosine of A? Remember, we talked about these type of triangles before and how they make three similar triangles here. So here's A, B, C. We have the medium-sized triangle, okay, which had sides of D, B, oh, that's not right. Those are flipped. Remember, the right angle is actually down here at D, and then it runs over to B, and here's C. And we have the small triangle, okay, which once again has a right angle at D. The short leg is DA, and the long leg is DB. So if we look at angle A, right, cosine of A is the adjacent over the hypotenuse, okay? In this triangle, we can also figure out the cosine of A because it's the adjacent over the hypotenuse. So there's actually two values. So the cosine of A could equal the adjacent, which is AB, over the hypotenuse AC, or it could equal in the small triangle side AD over AB. And now we're just looking to match up. Here's AB over BC, that's the wrong side. BD over BC, this is not the right ratio. BD over AB, that's not the right ratio. I'm out. Also, keep in mind, we're only looking at these two triangles, but the thing we have to remember is that this angle C is equal to this angle C is equal to this angle B, and this angle A is equal to this angle B is equal to this angle at A. So all three triangles having these letters in the same spots means their angles are equal. So this side is also, took me a second here to catch this one, would also be true. And the cosine of angle A is also equal to the cosine of this angle B and the cosine of this angle A, which means it's also equal to BD over BC. And so even though we said these weren't included originally, this one is. And so this would be our answer. Okay? And it has to do with the fact that these three triangles are similar. We talked about this before when we did similarity in right triangles. When we draw them out, we can see the angles are in the same position, and then the ratios of these sides all have to be equal. All right. Next one. This is one where you're going to definitely want to draw a picture. We have triangle MCT where T is 90. So we're just going to draw ourselves a right triangle. Doesn't have to be super accurate. Okay. The only other thing I would say is that TM is the smallest. So since I know that angle T is the right angle, I would put angle M down here since that's the smaller side. And that means C goes up top. So MC is 85, CT is 84, and TM is 13. Now, if you flip these around, it's not going to make a difference. It'll just look weird, okay? And we want to find the sine of angle C. So here's angle C. Remember that sine is so that's opposite over hypotenuse. So opposite is 13, and the hypotenuse is 85. So the sine of angle C is equal to 13 over 85, and that would be choice 1. All right. Once again, so if ABC, where angle C is a right angle, the cosine of A is equal to the sine of B, right? So if C is a right angle, that means that angle A plus angle B is equal to 90, right? Because we have a right triangle with C being the right angle and the two other angles being A and B. If this is true, then the cosine of A is equal to the sine of B. So the sine of B is the same thing. That's it. You just match them up. Number 19. Okay, a little bit tougher, a little weird diagram here. So let's see how it works. In the accompanying diagram, a triangle ABC, B lies on AC, and line BD is drawn so that the two angles which are given are 27 and 30. BC is 9. We want to find the length of AB to the nearest tenth. Okay, so here's the key. We already know what this length is. Okay, the problem is that this triangle they're giving us, triangle ABD here, is not a right triangle. Okay, so in this triangle, Sohcahtoa does not work. Okay, not a right triangle. So we can't use this triangle here. Instead, we have to go and look at the really big triangle all the way across. We have to apply our Sohcahtoa to the really big triangle. Sohcahtoa works. Okay? So instead, we're going to be looking at this big angle right here, right, which is 57 degrees. And we're going to pay attention to this one. Now, if we wanted to figure out what this length is here, which is really just AC, okay, I'm going to need to know what this side is. I need to know another side length. And I don't know what CD is yet, but, big one here. In the small triangle, I can actually figure that out. So in BCD, okay, where this is 27 degrees and this is 9, I can figure out what this length is, and this would be the same length. It's the same triangle, okay? So in this triangle, we have the opposite and the adjacent sides. So we're going to go ahead and use our TOA, or tangent, okay, of the angle is equal to the opposite 9 over the adjacent x. We're going to cross multiply to get 9 is equal to x times the tangent of 27, and then divide out by the tangent of 27 for our answer. Okay, so remember, we're doing 9 divided by trig tangent 27. Oh, we forgot the divided by sign. Let's go back here. Divided by. Okay. Enter. Let's make sure that's what we wanted. There it is. And then we get 17.633. Remember, we talked about this earlier. Try not to round this crazy number. Okay. 17.66349. But we are going to let x equal this number. 45495. We're going to let x equal this number. So x is that number. Whenever you write x, you're actually writing that number. Okay? That's what x equals. So let's just highlight. This is what x equals. So when you write x, that's what you're writing. So in the really big triangle now, really big triangle, right? We have x, we have that 16 point whatever. Okay? We have a 57-degree angle. And now we want to figure out what the length of AC is. We'll call this y for the time being. Okay? So now, right, we have the opposite and the adjacent in this triangle. So now we're going to go ahead and do the tangent of 57 is equal to opposite y over adjacent x. And remember, this x is really that number. Okay, so we're going to go ahead and cross multiply. So x times the tangent of 57 is equal to y. So x times the tangent of 57 is equal to y. And remember, that's really this number. So now on our calculator, okay, we're going to go and put x, which is this big number, bring it down, times trig tangent of 57. All right, and it says round to the nearest tenth. So that's 27.2. And that would be the length of AC. Oh, this is the length of AC, right? So this is 27.2. Now, in order to get AB, we really need to take AC and subtract away BC. So AB is equal to 27.2 minus 9, and that means the length of AB is, well, if we want to be super accurate, we should probably do this. But if you just did 27.2 minus 9, you're still going to get 18.2 either way. Okay? So 18.2 would be our final answer. All right? Good work. Okay. Now, if we did round this and put 17.7, would we get a little different answer? I don't know. Check it out later. All right. Length of the hypotenuse of a right triangle is 34. One of its legs is 16. What is the length of the other one in inches? So once again, right triangle for yourself. Right hypotenuse is 34. Okay. one of its legs is 16. It doesn't matter what the other one is. We're going to label the third leg as x. This, once again, is only sides here that we're talking about. So that means we are going to be using our Pythagorean theorem, not Sohcahtoa. Okay? So if we want to apply this formula, C is always going to be our hypotenuse, and A and B for the legs. So 16 squared plus x squared is equal to 34 squared. And if you were using the C squared minus B squared formula, equals A squared. Totally cool to use this as well. 34 squared minus 16 squared. Don't forget I didn't forget about you either. Okay, we're going to square those numbers. So 16 squared, 34 squared. All right, 1156 and 256. All right, subtract that away and solve. And we're going to get x squared equals, so minus 256 is 900. So this would just give you 900 right away. And then you would just take the square root when you go through here. So x is equal to 30. All right, and that would be the other leg. And that's it. All right, last question. We made it. As modeled below, this is an old Regents question here. A movie is projected onto a large outdoor screen. The bottom of the 60-foot tall screen is 12 feet off the ground. The projector sits in a horizontal distance of 75 degrees from the projector. We want to find the measure of theta. And this is the opposite of this question. You guys remember how we subtracted the side lengths to get this? Now we're going to actually subtract the angles. So we want to figure out what this angle is first. Okay. And then we want to figure out what this really big angle is. So you got to remember that they're coming from two different triangles. They're coming from two right triangles. One of them is this bottom portion of the triangle here. And the other one is the really big triangle here, okay? And so once we know the measure of the two angles, then we can just subtract them, all right? And this whole side, because that's what we're using, would be 72. So for the blue triangle, we're trying to find this angle. We'll call this one x, okay? We have our opposite leg and the adjacent leg that are given to us. The hypotenuse would be over here, which we're not using. So we're going to go ahead and do our Sohcahtoa and use, hopefully you said tangent, okay? So the opposite leg is 12, the adjacent leg is 75. And remember, we're looking for tangent, so we're going to use that tangent inverse, okay, of tangent x. And then the tangent inverse of that 12 over 75 here. So these are going to undo. We take our calculator, trig, tangent inverse, maybe 12 over 75. And that gives us 9.090276. Remember, we want to be accurate. We don't want to round to the end. So 9.090276. 92082. All right, and then in the really big triangle, we'll call this angle, we'll say y here, okay? So once again, we have the opposite leg, which is 72. We still have the adjacent leg of 75. So we're also doing the tangent of y, opposite over adjacent. Last question, then you can tell us whatever it is that you need to tell us. Okay? Taking the tangent inverse of both sides once again. All right, and y is going to equal, we're going to grab our calculator here. We're going to go to trig. That's right, tangent inverse, 72 over. And 48th. It's a side length in a triangle, kiddo. 0.83086060. 08. Hold on. I know you're excited to tell us stuff. Wait, is it 80? 08 606 721. And then all we're going to do to get the measure of theta is just subtract y and x. So take x away from y, or do y minus x. So theta equals, and we're going to take 43 point, right? Subtract away, and then round. Now, if you had rounded early, right? If you rounded early, you would have gotten 43.8 and 9.1 if you rounded the nearest tenth early. Most of the Regents questions are made where even if you round it early, you're not going to find yourself in a lot of trouble. Not yet. We're not ready yet. We're not ready. We want to be focused and make sure we're done. So you'll still get, in this case, 34, but notice that we ended up with 34.7 and it actually rounds up. So just be careful, because if you rounded early, okay, oh, you know what? Time out, people. It's 43.8, not 0.1. Okay, you notice that we will get the correct answer here, so just be careful. But nearest tenth of a degree, that's 34.7 degrees. Okay, that is it for today, and our special guest Kate has a message.
If you don't do any of your work, then you're gonna get mathematics.
An F minus? I didn't even know those existed.
If you don't do anything of your work, then you're gonna get a Z minus.
Z minus. Oh, I love that. Z minus. Can we give Z pluses up because it do their work? Yeah, all right, we'll give Z pluses up. All right, you guys have yourselves a great night. We'll see you tomorrow, hopefully.